100 millimeters of Krupp steel armor. In 1943, this impenetrable shell effortlessly deflected every single anti-tank munition the Allied forces could throw at it. Yet, this 54-ton apex predator of the battlefield was ultimately transformed into a steel coffin, not by enemy fire, but by the very gears and sprockets meticulously engineered inside its own hull. Welcome to DEFUNCT. Today, we are tearing apart the Tiger I tank. Let us strip away the mythology and execute a full 3D dissection of the Maybach HL230 P45 V12 engine and its catastrophic Olvar transmission system, exposing the fatal mechanical flaws that tore this beast apart from the inside out. Let us isolate the engine block and peel back the cast iron rear upper decking. Stripping away the heavy ventilation grates, we expose the beating heart of the Tiger I, the Maybach HL230 power plant. We will apply a Boolean cross-section cut right through the center of this 23-liter cast iron monstrosity. Notice the precise alignment of the 12 pistons, operating on a massive compression ratio to push out 700 horsepower at 3,000 revolutions per minute. To put that kinetic energy into perspective, that is the equivalent pulling force of 3 modern diesel locomotive engines bolted together, all crammed into a confined armored compartment, measuring just over 2 cubic meters. Watch the 4 dual Solex carburetors as we initiate the simulated combustion cycle. These carburetors are frantically atomizing fuel, demanding an astronomical fuel flow rate of 2.5 gallons of high-octane aviation gasoline for every single mile traveled. If we visualize the thermal dynamics using a thermodynamic overlay, you can see the heat index radiating from the cast iron exhaust manifolds immediately spiking. Within minutes of heavy combat operation, the ambient temperature inside this tightly sealed, unventilated engine bay surges past 150 degrees Celsius, baking every single rubber seal and gasket to the point of catastrophic brittle fracture. Now, let us trace the transfer of this immense rotational torque. We will make the rear firewall transparent and follow the colossal steel drive shaft as it runs straight through the crew compartment, passing right between the gunner and the radio operator, connecting directly into the Olvar EG66 MAC semi-automatic transmission located at the very front of the armored hull. This is exactly where German engineering hubris meets the brutal and unforgiving laws of physics. Let us completely dismantle the transmission housing, leaving the planetary gear sets and the heavy clutch packs floating in a 3-dimensional exploded view. This gearbox features 8 forward gears and 4 reverse gears, utilizing an incredibly complex hydraulic pre-selector system. Watch closely what happens when the driver shifts gears. As the high-pressure hydraulic fluid engages the massive steel clutch plates, an immense wave of shear stress violently impacts the planetary gears. We are talking about channeling over 1,800 Newton-meters of torque directly into these machined teeth to instantly overcome the static friction of 54 tons of dead weight. Every single shift acts like a heavy steel sledgehammer violently striking the gear teeth. But the transmission is only half of the mechanical nightmare. Let us zoom in closer on the Merritt-Brown dual differential steering mechanism integrated right into the front final drive assembly. To steer this 54-ton behemoth, the driver cannot simply turn a wheel. Instead, the system must mechanically brake one entire track while continuously sending full engine power to the opposite track. As we simulate a sharp left turn, observe the friction material on the steering clutch discs screaming under the immense kinetic load. the friction coefficient skyrockets, generating so much localized thermal energy that the hydraulic fluid circulating through the transmission instantly boils, exceeding 120 degrees Celsius in a matter of seconds. At this extreme temperature, the lubricating oil completely loses its molecular viscosity, transforming from a protective fluid into a useless, scorched sludge. The precision gears are now grinding bare-hardened metal against bare metal. You can visually track the microscopic metallic shavings shearing off the gear teeth, contaminating the remaining hydraulic fluid and accelerating the rapid destruction of the entire gearbox assembly. Let us shift our focus to the auxiliary cooling systems flanking the V12 engine block. By isolating the two massive cooling cyclone fans and the radiator assemblies, we can analyze another critical point of mechanical failure. These fans are directly driven by a complex series of power takeoff shafts connected directly to the main engine crankshaft. Running at nearly twice the engine speed, these fans must drag thousands of cubic feet of cold air per minute through the armored grating, just to prevent the Maybach engine from completely melting itself into a puddle of molten slag. We will initiate a particle simulation to track the airflow velocity. Notice how the heavily armored louvers restrict the volumetric flow rate by almost 40%. In the extreme heat of a summer offensive, the thermal load simply outpaces the heat dissipation capacity of the radiators. The liquid coolant boils, the pressure relief valves scream, and the cast iron engine blocks warp under the extreme thermal expansion. The internal microscopic tolerances between the massive aluminum pistons and the cast iron cylinder walls shrink to absolutely zero. Without adequate lubrication, the friction coefficient surges exponentially, and the engine completely seizes, locking up with enough violent rotational force to snap the primary connecting rods clean in half, punching a jagged catastrophic hole straight through the engine block. Before we move to the catastrophic failure in the freezing mud, we must examine the sheer mass that this engine and transmission are forced to drag across the battlefield. Let us strip away the interior components entirely and look solely at the bare welded hull. This is not a cast or sloped chassis like the Soviet T-34. The Tiger one is constructed from flat, massive plates of surface-hardened Krupp nickel steel armor. We will highlight the interlocking joints where the 100mm thick frontal plate meets the 82mm side plates. These armor plates are not merely welded. They are mortised and tenoned together like heavy timber framing before being meticulously arc welded by master craftsmen. This incredibly labor-intensive manufacturing process creates a structural rigidity that can easily absorb the kinetic impact of a 75mm armor-piercing shell, traveling at 900 meters per second. However, this invincible protection comes at a fatal cost of absolute mass. Every single millimeter of steel adds hundreds of kilograms. The total weight of the heavily armored turret alone exceeds 11 tons. We will calculate the static load resting entirely on the hull bottom. The Maybach 512 is not just moving a vehicle, it is desperately attempting to propel a rolling fortress. The sheer inertia of this 54-ton mass dictates that any sudden acceleration, hard deceleration, or sharp turn sends a massive shockwave of kinetic energy straight backward through the final drives, tearing into the transmission and finally destroying the engine crankshaft. The machine is in a constant state of mechanical war against its own gravitational pull. Now we must rip this pristine 3D model out of the sterile testing laboratory and drop it directly into the brutal reality of the Eastern Front in the autumn of 1943. Welcome to the Rasputitsa, the notorious Russian mud season. We will simulate the soft, waterlogged soil conditions underneath the tracks. Despite weighing 54 tons, the Tiger 1 exerts a ground pressure of exactly 1.04 kilograms per square centimeter. To visualize this, that is roughly equivalent to the downward pressure exerted by an average adult human, standing flat-footed in heavy winter boots. This seemingly impossible feat of weight distribution is achieved by the massive 725 millimeter wide, kilograms 63 stroke, 725 stroke 130 track links. But to distribute that immense weight across those wide tracks, German engineers implemented one of the most disastrous mechanical configurations in armored warfare history. Let us execute a full dynamic teardown of the Schachtellaufwerk, the infamous interleaved road wheel system. We will strip away the heavy steel tracks and the massive side skirts, exposing a labyrinth of suspension components. Focus your attention on the 16 massive 80-centimeter diameter road wheels overlapping and intersecting each other on every single side of the hull. We will make the outer hull plates transparent so you can witness the massive transverse torsion bars running across the entire width of the tank floor. These heavy steel bars are designed to independently spring each individual wheel, twisting under the immense weight to provide an incredibly smooth, stable firing platform, even while the tank is moving across highly uneven, shell-cratered terrain at 20 kilometers per hour. However, let us zoom in extremely closely on the microscopic clearances between these overlapping inner and outer road wheels. We are talking about horizontal gaps measuring barely a few inches between rotating steel discs. Now, we introduce a heavy particle simulation of thick, freezing Russian mud, heavily mixed with shattered rocks, battlefield debris, and wet snow. As the 54-ton Tiger plows through the devastated landscape, this incredibly dense slurry is violently forced upward into the deep suspension cavity under immense hydraulic pressure. The interleaved wheels act like a massive, unstoppable industrial blender, churning the thick mud and packing it tightly into every single narrow crevice between the overlapping steel rims. The calculated mechanical tolerances of the blueprint simply vanish in the dirt. During daytime combat operations, the tremendous physical friction and continuous kinetic energy generated by the rapidly moving suspension keep this mud in a semi-liquid state. But the fatal flaw completely reveals itself when the sun sets and the ambient temperature plummets far below -20 degrees Celsius. We will instantly freeze our 3D physical simulation. Watch the thermodynamic mapping as the water content trapped inside the packed mud undergoes a rapid and violent crystallization process. In a matter of hours, the soft slurry solidifies into solid ice, achieving a compressive strength of over 3 megapascals. This is not just frozen dirt. This is the physical equivalent of pouring hundreds of gallons of high-strength industrial concrete directly into the tank's intricate suspension system. The 16 overlapping wheels on each side are now permanently fused together into an immovable, solid block of frozen steel, rock, and ice. The entire left and right track assemblies are completely and totally locked out of any rotational movement. Now, let us simulate the catastrophic mechanical chain reaction when morning breaks. The panicked crew desperately attempts to break the tank free from its icy tomb before Soviet artillery dials in their coordinates. We will start the Maybach V12 engine. Watch the telemetry data display as the RPM aggressively surges to 3,000. The driver slams the heavy Olvar transmission into first gear and violently drops the main clutch. over 1,800 Newton meters of raw, unadulterated rotational torque violently travels down the main drive shaft, instantly multiplying through the massive planetary gear sets and slams directly into the front drive sprockets. But the heavy steel tracks absolutely cannot move. The interleaved road wheels are literally welded to the lower hull by tons of solid ice. The engine is now engaged in a brutal tug of war against the structural integrity of a concrete block. We will heavily slow down the physics simulation to capture the exact microsecond of catastrophic mechanical failure. The kinetic energy generated by the 700 horsepower engine has absolutely nowhere to go. It instantly reflects backward into the drivetrain as a massive wave of destructive shock. First, the hardened steel teeth of the massive front drive sprockets violently shear off under the immense shear stress, shattering outward like cheap glass under a hammer. If the thick sprocket teeth somehow manage to survive the initial kinetic shock, the colossal torsional load travels backward up the final drive assembly. The heavy steel drive shafts twist violently, exponentially exceeding their metallurgical yield strength in milliseconds, and violently snap completely in half with a deafening crack. The sudden, violent decoupling of the massive drivetrain instantly removes all physical resistance from the Maybach engine. With the throttle pinned wide open and absolutely no physical load to restrain it, the massive V12 engine instantly over-revs, wildly surpassing 4,000 revolutions per minute. The immense internal centrifugal forces violently tear the heavy connecting rods away from the massive steel crankshaft, punching jagged, catastrophic holes straight through the cast iron engine block, spraying gallons of boiling oil and raw aviation fuel directly onto the glowing red-hot exhaust manifolds. In a matter of seconds, the absolute pride of the German engineering corps erupts into a massive, uncontrolled internal inferno. To make matters worse, retrieving a disabled 54-ton Tiger required the towing power of 3 other Tiger tanks linked together. If they attempted to tow this frozen block of steel, the immense drag coefficient would instantly overheat and destroy the transmissions of the 3 rescue vehicles, creating a domino effect of mechanical death. They engineered a perfect, meticulous Swiss watch, only to throw it headfirst into the brutal, filthy slaughterhouse of the Eastern Front. The sheer perfection of its blueprints became its absolute death warrant in actual combat operations. This is DEFUNCT. If you want to see more billion-dollar military machines brutally dissected down to their very last bolt and pushed past their breaking point, hit that subscribe button right now. Next week, we are looking at the SR-71 Blackbird's Pratt and Whitney J58 turbo ramjet engine. Why did the absolute fastest aircraft in human history have to actively leak highly flammable jet fuel onto the runway just to survive supersonic flight? Do not miss it.